tonight we are working on section 10.4, adding and subtracting fractions with like denominators. Who can tell me what is the rule when you are adding fractions? Just regular fractions. RJ?
The denominator needs to be the same.
Need to have the same denominator, and then we don't really add the denominators. We only add our numerators or subtract our numerators. So we're doing the same thing, only now our fractions are a little bit fancier. We've got rational expressions, and so there's variables and trinomials and binomials, and so we're going to work with it. Now, the way I show my work is how I want you to show your work. So notice, number 1, I have x over 10 plus 3x over 10, okay? And we just really, since it's the same denominator, we write it all over the same denominator, and then we just really add our numerators. And so 1x plus 3x makes 4x. And then these are both monomials, so we can cross cancel. Is there a common factor in these monomials? Go. 2. So 2 goes into 4 twice, and 2 goes into 10 5 times. And so I'm left with 2x over 5. Okay, questions? Yeah.
So just to make sure, so when it's 10 at the bottom, you don't add the 10, but you only add the variable.
If I had 1/3 plus 5/3, would I add the denominator? No. We only add our numerators. When you're adding fractions, you never add the denominators. It would be 6/3 and reduced to 2. Okay, let's try the next one. I've got 5 over 7x minus 2 over 7x. Why don't you guys pause the recording and try that one on your own? Go, 1 minute. So this should simplify to 3 over 7x. Questions? Nothing to cross cancel. The next one, please make sure you're writing this down. So, when we're subtracting something like this, now we know our denominator stays the same. If that were a plus sign, it would be much easier. I mean, there's not much work we have to do. We just have to add our numerators. But since it's a minus sign, we have to do this. We are subtracting the entire fraction, which means the entire numerator. So that means I'm going to need to subtract that entire numerator. And of course, it's all over 5. I don't need to write the 5 again. Okay? So what we do is we have to distribute that, and then it becomes a negative 2m. And then I distribute it again, minus 1. Of course, I have this 4m, and it's all over 5. Now I can combine my like terms in the numerator. So, Andrew, 4m's minus 2m's make how many m's? 2m's minus 1 all over 5. So is everybody understanding that we have to distribute that numerator to the entire second fraction? Okay, questions? Okay, all right, let's try some more. Notice my PowerPoint works horizontally. I want you working step 1, step 2, and not adding the equal signs. These are expressions, not equations. All right, so try number 1. Go. Pause the recording. What do we do with number 1? Yep, what's it going to look?
You can't add anything specific because you don't have anything in common, so would it be 5n plus 7?
5n plus 7 over n plus 3. But remember, you're not writing that equal sign. Okay? Next one. We're going to have a y squared minus a 4y all over y minus 4. What do you think we could do with that numerator? How about Lily Mendel? Hold on. What'd you say? Factor what? Okay, and what's left? And then I have a y minus 4 down here. And now we can cross cancel our y minus 4s, and what's left? Y. Questions? Okay. No. Okay, we're in the middle of recording. Good time to ask a question like that. So we have the same denominator. What do you think we have to do to that denominator? Go, Dion. Factor. What multiplies to negative 35 and adds to 2?
5 and 7.
A positive 5, what?
It'd be negative 5 and 7.
Negative 5, positive 7, okay? So my new denominator is going to be a
It would be
negative 5, positive 7. Is that right?
Yeah.
Okay. So what is it going to be, Dion?
It's going to be x minus 5 times the quantity of x plus 7.
Good. Okay. And then in my numerator, Scarlett,
Yeah.
what is it gonna look like?
It's going to be x times the quantity.
No.
Oh, x squared minus x.
Okay. X squared minus that binomial. X plus 20. Okay, guys? X squared minus that whole binomial. That has to be distributed. X squared minus x minus 20 all over x minus 5 times x plus 7. Now what can I do with that numerator? Imani? What multiplies to negative 20 and adds to negative 1? Good. So it ends up being x plus 4 times x minus 5 all over x minus 5 times x plus 7. So now we can cross cancel, and I'm left with x plus 4 over what's left, x plus 7. Okay, can we cross cancel the x's? No, because we cannot take a piece of a binomial. Okay? Okay, next one. Pause the recording. Try doing this one on your own. All right. How might I factor the denominator? Let's go with Oliver.
You would GCF 2x.
2x, and what's left?
X minus 3.
And then I have x squared minus 9. Can I factor the numerator? Kaylin.
You can factor the numerator to x minus 3 times the quantity of x plus 3.
And then we have 2x times x minus 3. So I'm left with x plus 3 over 2x. Questions? Yes.
I'm confused on like
Wait. I'm sorry, I didn't hear you. Go.
So, I'm confused because it's 2x times the quantity of x minus 3.
Right.
X, y, so these are the two denominators. But then why does it just come out?
I'm sorry. Shh. Wait, what did you say?
Because we did 2x times the quantity of x minus 3 twice.
No, we didn't. We didn't do it twice. Oh, okay. When I'm adding, I see what you're saying. Here?
Yeah.
Twice? Okay, when I'm adding 2/3 plus 5/3, notice all I do is add the numerators. I don't touch the denominator. So it's 7 over 3. So I'm not doing that twice. It's the same denominator. That's why I put it over once. It's all over the same denominator. Okay? So now we're on to, all right. So, do you guys want to try these on your own?
Yes.
Okay, pause the recording and try the next two on your own. Okay. How do I factor that denominator, Jean?
So would you do x times the quantity of x minus 1?
Yep. And that numerator, I end up with 3x minus 3. Can we factor that too?
3 times the quantity of x minus 1 over x times the quantity of x minus 1.
And then we can cross cancel, and we're left with 3 over x. Okay? Next one, I'm going to have a 2x plus 2 all over x squared minus 1. So I can factor a 2 out. I'm left with x plus 1. I'm going to factor this to an x plus 1 times x minus 1. And when we cross cancel, we're left with 2 over x minus 1. Okay, questions? How's it going, Lily? Okay. Okay, try the next one, go. Pause the recording. Andrew, we're going to walk through it. We know what the denominator is. Whoa. What is the denominator, Andrew? No, the denominator. X plus 4 times the quantity of x minus 5. Okay, the numerator, it's 2x squared minus that whole second numerator, 2x plus 40. Now, you can't cross cancel or do anything until you distribute that, mix it, and refactor it. Shh. So, now what do I do with the numerator? So I end up with squared minus, right? We have to distribute it to both. Minus 40 all over x plus 4. I need you guys quiet, please. Times x minus 5. Okay, how would I factor that numerator now? No, it's not a lead coefficient. Of a 2. And what's left? Good. And now I'm left with an x plus 4 over x minus 5. Now, can that part inside of there be factored? What multiplies to negative 20 and adds to negative 1? Okay. Good. Negative and positive. So this then becomes 2 times x plus 4 times x minus 5 all over x plus 4 times x minus 5. What can I get rid of, Andrew? X minus 5. And what's left? Yes. You'll lose that extra factor of your GCF. Did you get a GCF afterwards? Well, actually, what did you do lead coefficient factoring? If you do, you might end up with one of your factors being like, I don't know. I think you're going to, I don't know. Let's try it. You should be able to, but it would still be able to simplify more. And in the end, you'll have to simplify it. So like if we did that, what multiplies to negative 80 and adds to, negative 2. So then you're getting, okay. So you get x minus 10. Does that, yep. X minus 10 times x plus 8. And then you have to divide it by 2. Divide it by 2. You get x minus 5. But what you're missing plus 4 is you miss your GCF. You lost it. It gets lost in there.
Does it still work? But
No, because you're missing this, and that ends up being the answer, because then you'd be with x plus 4 times x minus 5. They cross cancel, and you're left with 1, and really the answer is 2. So you can't lead coefficient. You need to get that GCF out first. It's always the first step. And that, my friends, is our lesson.